Okay, we are still waiting for 5 more students to come in. Two more not yet in. Okay, never mind. Good morning to everyone. I'll just share on the proposal, right? Uh, Presentation, what you should have. So this is the standard proposal slides from UCSI University, meaning that if you are doing a proposal, these are the basic things that you should present in your proposal. Okay, so this one project title, you put down your assignment title and then the name of all the students and the student ID, and then the overall view, background of the studies all in point format with citation, all right? Like for example, Malaysia, the background like other developing country, okay? Depends on the multinational, all right, as a source of technology to enhance technology capacity. Then you put down your citation, right? Just a short sentences, more like format, So here given the guidance given is maximum 2 slides only on your background, okay? And then problem statement also in point form, all right? So like other developing country depends on primer to enhance, you just put like this, Also problem statement, maximum is 2 slides. All right, significance of the studies, only 1 slide, okay? 1 slide only. Again, also point format with citation, all right? And then you put down your research objective, okay? And then research questions, all right? So you have the general objective, okay? So if you don't have specific objective, it's okay. Then you just put down your research questions, all right? Because when you reach masters, especially up to PhD, right? The requirement is that you must have one research question, one research objective. The research objective must map to your research question. But at this level, you don't need to have so many research questions. Just one research question would be fine. If you have a few objectives, okay, but they were answers to just one research questions. All right? Clear? Any problem here? Clear, huh? And then literature review, all right, you set up like this, okay, the study context, okay, all right, and then whatever you have, all right, if there's any theory you use in your study, you put it in, okay, and then your IV and DB, okay. Any questions? Study context meaning you are doing it in Malaysia or in Cebu or whatever it is, okay, your environment of your study. If there's any theory, put down your theory. If there's no theory, that's fine. Here is your IV and your DB, okay? So you just use one slide for association between your variables, okay? This explained under the premises of SY theory, highlight, okay? And then your hypothesis. Okay, literature review. So if you have your conceptual framework, all right, you put down, draw your diagrammatic presentation of what you are doing, your IB and your DB. Okay, so be very careful when it is a moderating variable. It moderates the relationship between social influence and behavior intention you touch here. Okay, if it doesn't moderate, you don't draw out your lines. All right. And then research methodology. So this is very basic, So it's more or less standardized since ours is also doing quantitative methods, okay? So you put down your type of study. Yes, ours is also a cross-sectional studies, okay? Philosophical approach. Yes, we are also doing positivism, okay? Quantitative analytical methods to address issue, okay? So your population and your frame, okay? So who is your, like this one, all the IJB company registered with this registrar of company. So some of you is the SME, you put down all the SME in Cebu or whatever. Is that clear? Or all the consumer of this booth, all the working adults, all right, you put down. And then your sample size, and then power analysis, this one because they are using G power, okay? So if you are using G power, you have to specify your effect size at 0.15, alpha at 0.5, statistical power at 80. All right, the sample size was adequate and well done above the minimum required. All right, minimum required is 98, but they may have 100 or then 128. Okay. All right. And then sampling type, what sampling method do you use? And then unit of analysis, as this one is company, so it's organization, all right? Instrument, your questionnaire, you put down, it's 5-point, Likert scale, or 7 or 4-point, depends on you. Is that clear? And then all together, how many items in the questionnaire? 94. This is yours, take down, all right? Data collection method, you use what? Structural mail survey. We don't use mail survey, we use what you will be using Google form. Is that clear? All right, Google form survey. All right, and then what are the data you have? All right, primary data and secondary data. All right, data analysis. All right, what do you do? This one is SPSS. They're using exploratory data. SPSS. You do the normality test. All right. This one just mention about normality test, but whatever you have, you put down. And then reliability test also fixed at 0.7. Hypothesis tested, all right. They use Pearson correlation. And then they use multiple linear regression, all right. Okay. So these are things that if you're using SPSS, this is what you should put down, all right. And then research instrument, this one you don't have to show all the whole research instrument, just the first, the variable, and then a few, and then the source. Is that clear? All right? And then with that, you finish. Okay? Any question? You know how to do this PowerPoint? Or no problem, huh? So some of you have already emailed me your draft. I will go through whenever I can, all right? I will give it back to you. Okay? Then you can improve and then you can finalize everything, all right? So we will do this presentation in week 12. We will finish Smart PLS, then you will do your presentation already. Huh? Any question? Anybody? Regarding your assignments and then your PowerPoint presentation on your assignment. Any question? Hello? Any other? No, eh? Okay, what is this? Okay. WhatsApp. What you have? What do you WhatsApp me or not? Have you WhatsApp me? Yesterday all they are publishing already, huh? Okay, I will read through, huh? Is it yesterday gone, huh? How come no, huh? Can you ask me now what is it? No lah, huh? Oh, so sorry, where is the email? Where is the text, huh? Yesterday, huh? Okay, your number is 4668, is it, Jialing? Jialing? Is it 4668 at the back? Yes, okay, I will reply. Okay. So the highlight sentences. Or sampling size, okay, I will look at it. You can turn it in. I haven't give you the number. I have not given you the turn it in ID, right? Yes, you all can put in turn it in. All right. If you have amended, and then if you want me to go through again, you can. And then if you want to turn it in, okay, is that clear? All right, but I have not given you the turn it in ID, huh? I give already, Oh, okay, good. Do I change or not? Okay, I give already, then that's good. Okay, I cannot remember, because all right. Okay. Already, I did this one. Okay, the password is BB204, is it? Yes. Okay, good. Thank you. Is this the one? I create a new one last time. Okay, never mind. I will reset the one, huh? Okay. Good. All right. Okay. So yeah, if I make correction for you, you want me to check through again, okay, huh? But you have to give me time, huh? And I have quite a number of things at hand going on, okay? So you give me time, I will, but definitely will be before, huh? Because as you do your presentation, you will still have to make your correction and then you do your submission, all right, in week 13, okay? Everything must be submitted in week 13, all right? Okay? So I will definitely, if you give me the draft, I will go through. Definitely is before week 13, okay? So before your presentation, I try to give it back to you. If not, but week 13, you must submit. So it's definitely before your submission, okay? All right? So this presentation, you can, in your group, you can prepare already. And then for presentation, right, you must take turn, everybody must present. Is that clear? So yes, all right. 19 July is okay. I said 19 July, meaning 19 July, everybody must finish your assignment. And then, all right, you treat it as first draft for me to go through, and then you do your presentation, okay? Then we submitted on 13 of week 13, all right? Because I don't have the calendar here with me now. Okay, later I will take a look, okay? Last time I give you the date is 19 July, right? Assignment due, then it is that due date, 19 July, okay? Then you will do your presentation, then only then you submit the final copy, okay? Any more questions? Any more question regarding your assignment? Clear? Okay. Any more question on assignment? All right. So for this assignment, 19 July, everybody make sure you must finish already. Later, I will just go up, I will check on which day you'll do your presentation, okay? Then, all right, then after presentation, if there's any correction, you will do it. Once you do it, right, then you send me the PDF format and then the Word format, okay? And then your PowerPoint slides. That is the final submission. Okay? One group's presentation is about 15 minutes with all these slides. You see, we only have how many slides? 2, 2, 2. Let me see. We only have 9 plus 2, only about 15 slides. Okay, not more than 15 minutes or half an it's okay hours. I'm quite flexible, okay? All right, we'll just need one section to finish all the presentation, okay? All right. So no more questions with your assignments. All right. So next we go to the Smart PLS, okay? So your final exam also on Smart PLS, all right? Okay, final exam also on Smart PLS. All right, we should look at this. Smart PLS is actually partial least square structural equation modeling. All right, this is one of the latest technique researcher use, okay, for analysis. All right. Okay, you can actually download Smart PLS as a trial version that you can use it for 1 month, I think. Okay, for 1 month. But you must remember, if you download on this laptop once as a trial version, the next time you cannot download anymore as trial version, you must purchase. In school, academic office, reception counter, I install Smart PLS there. If you want to use, you can use in school with that. Okay, that is a licensed Smart PLS. Okay, for your final year project. So for your final year project, I'll encourage all of you to use Smart PLS to use, okay, to analyze instead of SPSS. All right, so you download latest version Smart PLS. You can download. This is how you download, okay? They give you 1 month trial free. Okay, so trial for 30 days, you enter your email. This one, no problem. You can go and do it. All right. But now you don't use it. Okay, you don't download, but if you want, you can practice, and there's many videos on YouTube on this Smart PLS. Okay. So this is how you download, okay? All right. and then activation for 1 month. You subscribe to this professional. Don't use this student, okay? Student, they only limit your data entry to 100 only. Don't do that. Use professional. All right. So this is how you download. Okay. All right. I will not go through. Very simple. You just follow. Okay. You can watch YouTube. This one for downloading. All right. So why structural equation modeling? Okay. Structural equation modeling, right? It's called the second generation data analysis technique, okay? So, to the first generation, contrary to the first generation, such as regression, SAM enable researcher to answer a set of interrelated research questions, okay? So instead of just regression, right, this structural equation modeling, they can do more, all right? They answer a set of interrelated research questions by modeling the relationship among multiple independent and dependent constructs simultaneously. So instead of just x and y, right? Just analyze x and y as in the regression. This SAM, right? They can answer the interrelationship, all right, among independent variable and dependent variable, okay? So this capability, all right, for simultaneous analysis, it differs greatly from most first generation regression models. Okay? Like this first regression model, linear regression, you have so many logic, ANOVA, MANOVA, which can analyze only one layer of linkage between independent variable and dependent variable at a time. Okay? All right. So you see, the first generation is just y and x. All right. So this structural equationing modeling, some more, it can analyze the relationship among multiple independent and dependent variable, not just y and x. Okay. So that's why it is more powerful. So if you use SPSS, it's only this regression only. So fundamental as this structural equation modeling, we have this covariant-based structural equation modeling, common factor modeling, and then you have this variant-based, okay, composite modeling. This is PLS SMART. This one. And then we also have this. These are all the terms we use in this structural equationing modeling. Okay. All right, so we are looking at SMART PLS. This is composite modeling, all right? These are all the terms that we are using. So we have this covariant-based SMART structural equationing modeling. This is to minimize the difference, all right? This one, covariant-based, between theoretical covariance metric and sample covariance metric. So this one is to minimize the difference between theory and your data, empirical, the data that you collect. Theory, confirmatory oriented, just to confirm the theory only. You have the theory there, and then you collect your data. Data fit into theory, it confirms, okay, the theory is right. All right, parametric test prevail, okay? That means it must be normal data, all right? So it is for small to medium-sized model, all right? So, but this variant-based smart structural equation model, it tries to maximize the explained variance as exogenous random construct, okay? This one is the variable, okay? And then focus on predictable ability of the model or theory development oriented, okay? So they explain the independence variable, and then it focuses on the dependence variable to explain the theory. It is the only non-parametric test, all right? That's why it can accommodate small to large model. So it can be used for not normal, no normal data. All right. So it can be for small and to very big. That's why Smart PLS is very useful. It's very handy. Most of the research questions, all right, you can use Smart PLS. Okay. Any question with this? All right. So software, you have all this software for covariant base. These are okay. The most common one we will see, all right, is this MOS. That's why before people use MOS. All right, for this structural equation modeling, now we use Smart PLS. This tool is the more common one, okay? All right, so if you further your study in master's and PhD, right, then you will know that there are so many software available, but the common one is people use MOS before, all right? But now the common one is people use Smart PLS. But there's also some people who use Endacol, okay? All right. I heard of this Endacol, but I don't know what they say. All right, that this what PLS, okay, there is, but we don't need it, so we don't really go and study it, all right? But these are the software that is available now, all right? Okay, so majority people now are using Smart PLS, but some of them they also make use of this Endacol. Okay, all right. So for those who are very good in mathematics, all right, they can understand this Smart PLS better. Okay, so when we have this model like this, so this is one of the model. You see, it's so complicated. You can use Smart PLS to analyze the interrelation among all these variables, okay? All right, so you can see Smart PLS analysis. So if you are using Smart PLS analysis for your chapter 3, you can write like this, okay? You say Smart PLS, all right, will be used to engage to perform the partial least square structuring modeling. You can work like this, all right? So the technical technique, this one allows researchers to test the sets of interrelated, you see? That's why we say Smart PLS, right? It helps you to analyze the interrelationship among the variables, okay? Concurrently, by appraising the relationship among multiple exogenous, so exogenous is independence variable and endogenous is the dependence variable, right? In a theoretical model, okay? So two steps approach is conducting PLS. SEM was strictly allowed for outer measurement and inner structural model evaluation. Okay, so subsequently, the study test for common method bias, all right, moderating effect, all this was adopted for two reasons. Okay, so they also do this, and then you explain why you choose Smart PLS was suitable for prediction and theory development in obtaining maximum variance explained. Okay, all right. If you are using Smart PLS, this is the reason that we all use all the time. This is opposed to covariant-based structural equationing model, which is to confirm the fitness of theoretical foundation with the observed data. Is that clear? And then Smart PLS is suitable for complex research model, okay, with multi-facet construct, all right? As the study extends the UTAUT model with flow theory, all right, so this one explain this this conceptual framework, they are using this UTAUT model, okay? So if you are using Smart PLS in your chapter 3, you can follow this style to write, all right? So these are the textbook on Smart PLS. In the library, we do have some textbook on this, okay? So you may go and take a look at this textbook, all right? So the basic structural equationing model, we have this exogenous, endogenous, all right, this one, okay, so you have this exogenous and endogenous variable, okay. Exogenous, all right, is the independence variable in the structural model, okay. This one is structural model, exogenous, okay. Endogenous is the dependence variable, okay. I always get exogenous and endogenous confused, independence and dependence variable confused. All right, but you try to know it. Exogenous is independent variable outside. All right. Endogenous variable is the dependence variable. Is the random variable here. The smart PLS, they try to use the word random. Okay, random variable. Okay, it's the same. It's the same as independence variable and dependence variable. All right. Okay, now. Okay, so the basic model is this, You have exogenous model and then you have the endogenous model. All right. Okay, random and observed variable. So you see, random variable is the construct that are abstract, complex, and cannot be measured directly. All right. So this one. Okay, random variable. They cannot be measured directly. That is your variable. Okay, that's why you have different item. The different item is observed variable. Okay. You have your questionnaires, right? You have your variable, and then you have different items here. Okay, different item here. All this item is observed variable. Okay? Random variable is your independence variable, your dependence variable, but these are items. You have all the different item statement to measure this variable. Okay? So there are observed variable. Okay? Observed variables, observed variables, okay? These are observed variable to measure this y. Random variable x and y, all right? So you see these are inside. All right, so this is one. This one, they just look at gender and age, the moderate, mobile, tourism, shopping behavior, all right? Okay, so you can see here, you have the statement, okay? All right, so this one, perceived ease of use, and then you have all this statement here, okay? All right, okay? So all this statement is the observed variable, okay? This is the random variable. See that? Observed variable, and then this is the random variable. All right? Okay? All right, so we have this outer model. All right, so this is outer model, All right, reflective measurements model, allow errors from construct to indicator, So this one to indicator, we call it reflective, okay? The relationship between indicator and construct in a reflective measurement model is known as loading, all right? So this is the loading, okay? This one, the error, we call it loading, okay? And then reflective model, right? Meaning the error is pointing to the item, okay? All right, item, okay? So the dependence variable here, right, is measured by this That means it is reflected by this item. Okay, we call it reflective model. Okay, all right. So reflected in our all these statements, it must be structured in a reflective manner, huh? All right. So this inner model, this is the structure inner model that is between the relationship between the variable, okay? And then this is the item. Item, we call it loading. Structural model explaining the relationship, all right, between the Langdon's variable. This one inside here, between the Langdon's variable is the structural model, okay, inner model. The relationship between the Langdon variable is known as the path coefficient. So this arrow here, we call it path coefficient, all right? It's the relationship between the independence variable, okay? The item here load on this variable, okay? We call this item loading, okay? All right? Okay, so you see here, this one and dependence variable is measured by item 1, 2, 3. So what is the weight here? It measure this one y measure this y how much. This indicator here we call it loading. Okay, we call it loading. Indicator and construct reflective measurement model. We call it loading. All right. Okay. And then here, dependence and independence variable, we use path coefficient to measure how much is the relationship. Okay, right? All right, so can you see here now? Between dependence variable and independence variable is the structural model, the red line here. Okay, and then the item, individual item, measure individual dependence variable, that is outer model, all right, or the measurement model. Okay, all right. So when the arrow is pointing towards X, all right, is formative model. Okay, all these items form this. Okay, when it's reflective, meaning that this variable is reflected by this few item. Okay, so this, when you do the PIS analysis, right, it will show you whether this arrow is pointing here or this arrow is pointing inside. Okay, so the basic idea now you must have is that we do this independence variable, all right, affecting dependent variable, that is called inner model, all right, or structural model. Okay, the relationship between independence variable and dependence variable is measured by this path coefficient. We'll take 2 minutes break. in yet, one more not in, huh? Okay, all in, right? Okay. So you see, so you just have to visualize this diagram in your mind, all right? So the structural model is this independence variable and the dependence variable, okay? And then all the individual items, all right? Make sure this variable is loading, okay? That is outer model, all right? So as you draw up the diagram, it's marked PLS, all right? It will be something like this, okay? All right, so this will be something like this, all right? So you have all the individual item, indicator, measure this dependence, this variable, okay? All right, these are reflective model, okay? So step by step, measurements model assessment. All right, so we have this assessment of measurement model. All right. Okay, so this measurement model, right, to assess relationship between indicator and the Landon's variable, okay? So this one is the Landon's variable. Okay, the measurement model, you want to measure all your items, measure your Landon's variable, okay? So we have two types, either reflective or formative, okay? Like just now I tell you, reflective is arrow pointing out to the indicator. Formative is arrow pointing into the the Landon variable, okay? So assessment criterion, all right, reflective, you will have to carry out discriminant validity, convergence validity, and then internal consistency, all right? And then for formative, you have to carry out convergence validity the same, and then collinearity, and then weight and significant, okay? So you can see these two differences, all right? Reflective, arrow pointing to the indicator, okay? Formative, arrow pointing to the Landon's variable, okay? So you see now, if it is your model come out is formative, you do these three types of tests: convergent validity, collinearity, weight, and significant. If it is reflective, you do discriminant, convergent, internal consistency, okay? All right, so reflective model assessment, internal consistency. All right, internal consistency is measured by okay. All right, reflective models, internal consistency, we use Krobach alpha. All right, we can also use composite reliability, and then we can also use Dirac Henseler rho. Okay, rho, we just call it rho. All right, so these three all measure internal consistency. All right, meaning that all these variable, the item, they are consistent. Okay, it measures this variable, okay? Krobach alpha, composite reliability, or rho, okay? And then convergence validity is based on factor loading, average variance extract, okay? So this one, in other words, it is okay. It is valid, this one convergence validity. And then discriminant validity, we use Funnell and Lacker criterion, cross-loading, HTMT, So we will study what is this later, okay? So these are the few testing. It will be generated by Smart PLS, okay, to make sure that your item measure your variable. When your item measure your variable, the relationship between the two variable, right? If there is relationship, that means we can prove the relationship is there because all the items that you use to measure that variable is acceptable, is valid, okay? It's consistent. That's why consistency and validity, okay? All right. So you see internal consistency just now. Okay, this slide is very important. This and the next one. So you see, reflective model, we do these three tests: internal consistency, convergence, validity. Okay. Internal consistency, we measure using alpha. So alpha, you see, alpha here, a value of 0.7 is regarded as acceptable. So this one you must know. All right. Okay. So Crowbatch alpha measure the reliability of a set of indicator. That indicator whether it measure what it is supposed to measure. Okay. The indicator is the reading must be 0.7. Okay. Later stage is 0.8 or 0.9 according to this Nannali. Okay. All right. Crowbatch alpha, the reading must be more than 0.7. Okay. And for this composite reliability, it measures the reliability of a set of indicators. Okay. Threshold and interpretation, right? Like Crowbatch alpha again. The reading, right, must be 0.7. Okay. And this row also, it must be 0.7. Okay. So these three, right, all measure internal consistency, reliability of the sets of the indicator. Okay. All right. So you can see here, example here, you have this composite reliability and then row. Okay. These are all above 0.7. The outer model was verified using reliability and validity. All right. So these studies, right, use composite reliability and row, all right, to test construct reliability. Okay. So it was found to be 0.9 or 0.98, exceed threshold value of 0.7. Okay. Indicating that the measurement was a good model. Okay. So this is how you, well, this one is cut and paste. Okay. So this is how you interpret. Okay. This value out is exceed 0.7. It measure, all right, was a good reliability. Okay. All right. So this is how. All right. So you have this. All right. Okay. This one, Crowbatch alpha all above 0.8 imply all the measures as good reliability. Convergence validity also achieve. They have this average variance. So you see average variance explained. All right. Okay. Internal consistency. Okay. All right. So now you can see here. Okay. So internal consistency. Now we look at convergence validity, all right? Convergence validity, so you can see factor loading, okay? Convergence validity is factor loading and average variance extract. So loading 0.78, all right, can explain at least 50% of the indicator's variance, okay? Loading of 0.4456 can be acceptable if it leads to average variance, all right, that is larger than 0.5. So in other words, your average variance extract, right, must exceed 0.5. Then there is this convergent validity, okay? All right, average variance extract exceed 0.5. Factor loading more than 0.708, okay? So here loading, convergence validity, loading value equal or greater than 0.4 are acceptable if the summation of loading, average variance loading greater than 0.5. So you must quote this, okay? All right, and then loading value greater than 0.5. If these are also greater than 0.5, this one is based on this burn. All right, this is Hulan. So you must quote these people. Is that clear? 0.6. Average variance extract greater than 0.6. Okay, you must quote, Loading value into greater than 0.7. The one is here. All right. Greater than 0.8, indicating a Langdon's variable at least 50% of the indicator variance. This is here. Okay. So it depends on your reading, and then you can use any of this author, this researcher to quote your reading, okay? So when taking into consideration smart PLS characteristic of consistently enlarged, it is important you should be careful in deciding elimination of an indicator. So meaning that with all the items, if they are below this, you have to delete, okay? It makes sense to eliminate an indicator only when the indicator reliability is low. Is that clear? So only then it will increase the average variance extract. Okay. So when this loading that you have okay, this one loading is below certain value, right? That means this item we go to delete. Okay. All right. Okay, you have to delete, Okay, so this one is another article. They are using this smart PLS to use. Okay. So they have the loading here. See, all this loading is above 0.7. Yes or not? Extract, variant, extract also above 0.5. Alright, see this one? All above, Okay, so in order to test reliability, alright, the year row A, okay, all the measurements are reliable. As row A exceed 0.7, convergence validity also found to be achieved. All right, average variance extract, these are higher than 0.5. Okay, all right, every individual construct outer loading, this one also higher than 0.7. Okay, so discriminant validity was examined. Okay, this one we later will come to HTMT. Okay. Any questions? So you see this loading above 0.7, this one above 0.5. Okay. All right, this one average variance above 0.5, alpha 0.7, composite also 0.5. loading also above 0.7. So very good. So you look at the comment how they interpret composite reliability and Cobras alpha test the reliability, alright? All these values are 0.8 and above. So it measure this imply that all measures of the construct adopted in this research have very good reliability. They have good reliability. So convergence, validity, alright, average variance extract are above 0.5, okay? And then outer loading above 0.7, okay? So this is how they interpret, alright. So assessing outer model, this is another way that you can interpret, okay? That's how you write in a chapter 3, you can put down assessing the outer model, measurement model, 2-part, and then structure model, you use the path coefficient, okay? Alright. So this one, better loading on this, okay? So this one is convergent validity, construct validity, loading, the average variance. Okay. So consistency done. Convergence validity, we are done. So now come to discriminant validity. Okay. For discriminant validity, we use 3 factors to indicate them. So these are Fresnel and Laqueur. Okay. And then cross loading, and then iterate monotrack ratio. Okay. Fresnel and Laqueur, the average variance extract random variable should be higher than the square correlation between Langdon's variable and all others variable based on this Fresnel and Laqueur. And then cross-loading of an indicator should be higher than its loading on all the others variable. So this one you remember the loading on itself should be higher on it assigned Langdon should be higher than all the others variable. So HTMT ratio, right? Is address the sensitivity of Fresnel and Laqueur and cross-loading variable. So this equal this attendant correlation between construct, alright? It must be close to 1. Alright? So HTMT must be close to 1, indicate a lack of discriminant validity. Okay? So you have 0.5, 0.9 inference, okay? So Fresnel Laqueur, alright, correlation matrix with the square of this average variance extract, okay? So this one, Fresnel Laqueur, is not applicable to formative measurement model and single construct. Okay, then this is an example. Alright, so you can see here, assessing, okay? Alright, so you can see here, it says this, the outer model, right? You wish this reliability. So they also use the composite reliability, and this rho A to test reliability, huh? So all this exceed 0.7, okay? And this average variance extract exceed 5, huh? Okay, so you can see here, huh? Okay, this is all the independence variable. All right. Okay, so the discriminant validity on the other hand will assess using Fenner-Lacker. Okay, combine. All right, table 5, this table, confirm this discriminant in which the root square of this were diagonally higher than the correlation figure with other construct. So this is what it means. This one performance expectancy and this, you see, this one performance expectancy and this one performance expectancy itself, this one 0.93, okay, is higher than performance expectancy loading with the other. Okay, so this effort expectancy also, which itself effort expectancy is higher than the others. Okay, so this one also, this one higher than itself, load with itself is higher. This is what it means. Okay, all right, square root of this for all the construct, okay, was higher than the correlation coefficient with other construct, then it is acceptable. Is that clear? All right. Okay, you see that or not? This one, all line is diagonally like that, Okay, so this confirms discriminant validity. Is that clear? Okay, you see that? All right, so this explains discriminant validity. Okay. All right, so this is the statistic formula between them. We don't have to know why, but you just need to know the threshold is this 0.8. All right, this one, HTMT, one threshold is 0.8, one threshold is 0.9. All right. Okay, so you can use bootstrap. Okay, does the 90% confidence include this? All right, yes, no, discriminant validity. If no, right, discriminant validity. Okay, you don't worry about this formula. Okay, we just need to know how to interpret. Okay, so you can see here this example. All right, this example, the HTMT they generate is like this. Okay. All right, so average variance, all right, they use criterion, okay, to test the convergence validity, all right. The outer loading should have value of 0.8, 0.70, 0.708 or higher, okay. So this average variance extract must be exceed 0.5 to be considered, okay, satisfactory, okay. All right, so you see this one, HTMT, when it runs is like this, okay? So there is a diagonally line like this, all right? Okay, so using this, right, you see that this discriminant validity is not an issue, all right, in the present studies, okay? So they also do bootstrap, there's no sign of this, okay? So all the constructs are empirical, distinct, and discriminant validity has been established, okay? All right, this is how you run this HTMT, so if there's a line there like that, okay, then discriminant validity is confirmed, okay? Any problem? All right, HTMT. So these are more examples. All right, how you present it, huh? You see this one? Reporting HTML output, huh? So you have this, okay? All right? It's just ways of reporting it, huh? You see? Assessing the discriminant validity, okay? And then for this smart POS, the author here, Christian and this Marco, they are expert in this smart POS. So you should read the article. They are the founder of the smart POS, okay? All right, these are some of the, all right, so cross-loading. All right, just now I mentioned, cross-loading on each assigned variable, right, should be higher than its loading on all the other variable, okay? All right, like performance expectancy, itself perform 0.9, okay? All right, expectancy, okay? So these are different ways, So assessing the measurement model, these are different way of writing it, You can read through and then learn the way to report it, All right. Okay, so the outer model, All right, so here reporting on outer model, different ways, to report it, Okay, so average variance extract you can use, and then HTMT, you see, discriminant validity, all right, it's not an issue, this one, in addition, all right, no sign on this, okay, so all the constructs are empirical distinct and have been established, all right. Okay, so you can see all the lengths on the average variance extract. This row A, you can report this figure. All right, HTMT, there is this diagonal line. Okay. All right. Okay, then you can see here. All right, these are extract, Okay. So this is one of the model, it shows. Okay, how to use Smart PLS. You can go and look at this video, okay? Then you can also learn from YouTube, okay? Any question with this? Hello? Any question? All right, the main thing is you must understand this is the part only, Reflective model assessment, okay? This one, base internal consistency, convergent validity, discriminant validity, and then these are the few tests that you will run, okay? All right, so later I will give you the interpretation of this also. This is the big picture, We have reflective, we have formative, okay? So we look at internal consistency, convergence validity, and discriminance validity, okay? These three. This is the one you generate, Okay, the rest, all this is different way telling you how you can interpret your reading, this one, or how you can interpret all this reading, okay? Any question? Okay, so next I'll just share on this. This is a summary version what you are doing. Okay, so validity and reliability interpretation. Okay, just now we already gone to Kropatsch alpha. Okay, this is a summary. It must be larger than 0.7. It will confirm internal consistency. Okay, raw A, all right, but it must be more than 0.8, but 0.7 also can already. It confirm internal reliability. Okay, composite reliability also, it must be larger than 0.7. It confirm internal consistency. Okay. Okay, so the acceptable value for composite reliability are as follows. 0.6 are acceptable. In exploratory research, 0.7, 0.9, it can be reported as satisfactory. Okay, so more than 0.9 are not desirable. It indicates all the indicators are measuring the same phenomenon. So unlikely could constitute valid reliability. Assessment of the construct. This one, if it is more than 9, okay, not so good, but larger than 7, it confirms internal consistency. Okay. All right. Then convergence validity. All right. Okay. So use this average variance extract. Just now I mentioned already, it must be greater than 0.5. Okay. Is that clear? So meaning all these items, they measure the sense variable. That's why it confirms convergence validity. Okay. So this is an example. Here, this one Kropatsch alpha or more than 7, this one more than 8 or more than 7. Average variance is more than 5. Okay. Okay, so this one convergence validity of the, okay. And then discriminant validity, it indicates the differentiate across measurements distinct by examining the correlation between the measures of potential overlapping all the items there, whether there's any overlapping or not. They are distinct from each other. Each of the items they are distinct. Okay. So this Penner-Laqueur criterion, right, to assess discriminant. Just now we have this and this average variance extract must be more than 0.5. Okay. All right. HTMT for this discriminant validity, all right. So just now we also mentioned this 0.85 inference or 0.95 interference. Depends on which one you are using. Okay. All right. So it is the ratio correlation within the construct to correlation between the construct. Okay. So with a confidence interval, all right, contain value of 1 indicate length of discriminant validity. Okay. If the value of 1 falls outside the interval range, it suggests that two constructs are empirically distinct. Is that clear? So this one HTMT, right, cannot exceed cutoff value of 0.9, all right? So if exceed, all right, it does not have this discriminant validity, all right? It cannot to confirm when it does not exceed 0.9, it confirms this discriminant validity, like this one. You see, HT 0.9 indicate there's a problem of discriminant validity. Is that clear? All right. Okay. So for this loading, just now also, it must be equals to greater than 0.7. So this 0.708, all right, is able to explain at least 50% of the indicator variance. This is from this hair, okay? All right. So this is the summary. Okay. All right. So you use cross-loading to assess discriminant validity. Okay. Each indicator should load high on its own extract but low on other extract. Okay. Remember diagonally. All right. So if all item loading are 0.7, it shows all the items are larger than the total cross-loading, which confirms the discriminant validity. Okay. So any question for today? These are the summary of the indicator that we will be looking at. You will run. Any question? Okay, this is how you interpret. You write it in your report. If you are using Smart PLS. Okay. All right. Any more questions? Hello. The second part for Smart PLS we will go through, and then I will also give you a video. Next week we will look at the video and then we will follow the steps. Okay. So if you want to download, you can download. All right. We will go through that on Tuesday next week. All right. Then you are ready to do your presentation. All right. And also later I will give you a Excel, no, a table. All right. From I hope all of you registered for your SPSS this Saturday or not. There is this figure data that you have to create in Excel first, and later I will email to you all. All right. You all put into your type it in Excel. What people can do, then we just share. Then we'll use that data, all right, for SPSS on Saturday. All right, hands on. All right. Any question? For those who have not registered, please register. I have a few names previously. Not yet signed up for SPSS. Any question on that? Okay, so what is it? Yes, later I will send you the all this the presentation slides, all this and the PowerPoint to Google Classroom. Okay, and then this one, right? This is the one, huh? You all, this one is in Word format, huh? Later, maybe one of you can. This is for our smart, for SPSS, sorry, not smart PLS, huh? This one is for SPSS, huh? Later, okay, you all type into Excel, huh? Okay, put this is in Word, all right? You have to put it in Excel. Then we will use this speaker, all right, to export to SPSS, sorry, huh? So you all can download free SPSS version 22, huh? Get ready for Saturday workshop, okay? So please do sign up for the Saturday workshop so that you will learn SPSS, okay? Which is something that you also need to learn, okay? And then Smart PLS next week, all right? We will. You got who got exam? Why put Saturday exam? All right. For some of you, you got exam, all right? Then the only choice is that you will have to join SPSS after your exam, okay? All right. Because the SPSS workshop start at 8:30, right? But you please sign in, You sign in. Okay, you sign in, okay? And okay or not? Sign in. If you have other appointment, please sign up for the workshop. You join later, huh? This is the one given by the professor, this Dr. Lau. So we will learn hands-on, so it's good, okay, So I will later also upload to Google Drive, all right? Then you all can get it, okay? So any more question? If no question, we will stop for today, okay? All right? Any more? Any question on that? No, Okay, All right, I will take attendance for the SPSS workshop also, So please do sign up. I know a few have not signed up yet, okay? All right, so if there's no question, we will stop for today, Bye-bye. Any question? Okay, bye-bye.